Welcome back to part 2 of Module 4, Lesson 4, Zero and Negative Exponents. We left off with a little discovery activity we've been doing to get a better understanding of negative exponents and why they are what they are. Now we're actually going to take a look at them in words, algebra, and with numbers. So in words, we would say any non-zero number with a negative n power is going to be the multiplicative inverse of its nth power. Well, that is about clear as mud. Let's break it down, and I want to mention this multiplicative inverse concept here. Remember, the multiplicative inverse, that is going to be where you flip the number. So what we're going to do in algebra here is we're going to take and say if x to the negative n, all we have to do, that x is over 1, we're going to flip it over, putting 1 over x to the positive n. That's literally all there is to doing these. And of course, your x value, that cannot equal to 0 because your x is going to be in the denominator now, and we cannot have 0 in the denominator. Also, we cannot raise 0 to a power. From here, we've got 7 to the negative 3. Because it's a negative number, we're going to use the, what's the term they use? Multiplicative inverse here, where we're going to flip it. So instead of 7 over 1, we have 1 over 7. And that's the same thing as 1 over 7 times 1 over 7 times 1 over 7. Well, 1 times 1 times 1, that's 1. And then your 7 times 7 times 7, that's 7 cubed. So essentially all you did is you flipped it and you took the negative sign away from the exponent. It really is this simple, guys. There is nothing to doing these things. You just have to memorize the rules of how they work. So let's actually apply these. The problem wants us to express the 6 to the negative third power using positive exponents. So we're going to use the definition of negative exponent. All we had to do, or we had 6 over the invisible 1, boop, we flipped it over, making it 1 over 6. And we kept the 3. So 6 to the negative 1 expressed as a positive exponent is, and yeah, I know they gave it to us, but I'm bored, so let's go ahead and write this down or type this in because it's going to be a little tricky here. 1 over 6, and now we got an exponent thing to go to that 6, which is going to be a positive 3, except it really is that simple, guys. Alright, it's your turn. Stop the video, solve this problem. I mean, we're talking no time at all it should take you. And there's your problem to choose from. Did you get it done? I mean, it's not that hard. B is the same thing as b over 1. So we can go, boop, 1 over b, change a negative 4 to a positive 4, and boom, check your answer. That really is all there is to solving this. So, how would we go the other direction? Well, if it's 1 over c to the 5th, all we have to do is go, boop, pop it back up to where it's c over c to the negative 5th over 1, also known as just c to the negative 5th. So when you do that one, what's your final answer going to be? Well, it's going to be c exponent negative 5, accept, and check. So it's just going backwards from the way we did the previous problem. Now it's going to be your turn. I mean, take a look at it. 1 over 8 to the 3rd. What's the answer going to be? Yep, that's right. It really is that simple. 8 exponent negative 3, accept, and check. Nothing complicated at all about doing these problems. Well, almost nothing. What happens if they give us a problem like this, where we now have a common base of 5, one has an exponent of 3, and one has an exponent of negative 5. We can use the product of powers property, which means that we would be taking and adding a negative 5 to this one. Let's see how they actually say to solve this, because this could be kind of interesting. So they gave us a problem. 5 cubed times 5 to the negative 5th. As we've discussed, your common base is 5, and the product of powers property says you add the powers. Well, what are we adding? We're adding 3 plus the negative 5, which you see right here. Right there, I call that an ugly problem. Let's see if I can make that a little bigger for you. We call that an ugly problem. So how do you make the ugly problem pretty? Well, by multiplying the signs. That meant you had 3 minus 5, also known as a negative 2. So you would write that as 5 to the negative 2 using the exponent version. But wait a minute, we want this to have no negative exponents in the end. So to get no negative exponents, now we're going to flip it 1 over 5 squared, and from there you could take and even say from there 5 times 5 is 25. You get 1 over 25, which you could put right there if you want to. I'm not going to, but that would be showing your work on how to take and change the expression in simplest form, which means it's going to have no like basis and no negative exponents. So honestly, this right here would have been the answer to their initial question, and they took it even further, going all the way to 1 over 25. And now it's your turn. Go ahead and stop the video, solve this problem, and then pick out which one of these 4 answers is going to be correct. Let's take a look at how to work it. First thing I'm going to do is acknowledge the fact we have a common base here of n, and then I have the exponent negative 8 and 2, and since we're multiplying the common base with the different exponents, it's going to be negative 8 plus 2. That means signs are different. Find the difference, which is 6. Sign in front of your largest number. That's going to become a negative 6. Now, if we don't want that to be a negative exponent, which simplest form means it cannot have a negative exponent, we're going to take the reciprocal of it, make that 1 over n to the positive 6, and at that you have your final answer. Come back over here. That would end up meaning D is going to be the answer we're looking for. But what if we were asked to divide problems with negative exponents? Well, we've got rules for dividing things too that have common basis. So let's take a look at how your textbook went through it, and then we might or might not give you a little more detail on how I would do it. So you have w to the negative 1 divided by w to the negative 4. Remember, when you're dividing, you subtract the exponents that have a common basis. So here you have w to the negative 1 minus 4. Once again, this is an ugly problem. I make the ugly problem pretty by multiplying the signs. I don't think they're going to do that. No, they didn't. I would do that though. I'd have w to the negative 1 plus 4. Then I'd say signs are different. Find the difference with the sign in front of your larger number going in front of your answer. I'm not going to bother typing w cubed right there, but if you want to so you can hear that happy sound, well, you go right ahead and do that. This right here would be your final answer. And it looks like the textbook didn't think you had enough problems to work, so here's another one for you. Take and simplify that. Remember, you cannot have any negative exponents in your final answer when it's in simplest form. Go ahead and do that now. Did you get it done? Let's see what I'm going to do. I'm going to start off, of course, with an equal sign here. I'm going to change that to become 11 squared. Because we're dividing by 4, I'm going to subtract 4, which means that's going to be 11 to the negative 2 power. But that's not my final answer because there's a negative exponent right there. So from here, I'm going to take that and change it to 1 over 11 with the 11 squared, and that would be my final answer. This is the supporting work. That is what I must see, and if I don't see that on each and every problem of your homework, well, yep, you've done it just for fun. So we're going to have a 1 over an 11. The 11 is going to be squared. We're going to hit accept, and we're going to hit check, and we get the happy sound. Now, do you remember that introductory question where we were talking about how tiny snowflakes are and whatnot? Well, here we're going to talk about how tiny hair is going to be compared to the jewelry wire here. One strand of human hair is about 1/1000th of an inch in diameter. The diameter of a certain wire for jewelry is going to be a 10 to the negative 2 inch. That would be 1/100th of an inch, by the way. How many times larger is the diameter of the wire than the diameter of the hair? And it says to write the decimal as a power of 10. So we're going to be comparing the hair to the jewelry here. Now this problem is fairly complicated, but I'm going to run you through it here. Okay, let's start off with the hair. We're going to call the hair H, and that is they said that is going to be 0 1/1000th of an inch. Well, you could rewrite that as 1 over 1,000, 1/1000th, and from there you could say, well, that is the same thing as saying 1 over 10 times 10 times 10. You with me so far? If 10 times 10 is 100, times 10 is 1,000. That, of course, could be rewritten as 1 over 10 cubed, which we're going to stop right here where it says 10 to the negative 3. So the hair is going to end up being 10 to the negative 3. Now we're going to take a look at the jewelry. The jewelry, they already tell us, is going to equal to 10 to the negative 2, and they want to know how much bigger is the jewelry than the hair. So for that, we're going to set up a division problem. So we can find out how many times it is. I'm going to stop this section of video, and I'll come back in just a second and show you how to solve it. Now the problem has us comparing the wire to the hair. So the wire is going to go on top. That's going to be my jewelry wire, which is going to be, well, I don't know why I said n, 10 to the negative 2, divided by the hair, which has become 10 to the negative 3. Now when you're dividing exponents with a common base, that means we could rewrite that as 10 to the negative 2 minus a negative 3. But that gives me an ugly problem. So I'm going to make my ugly problem pretty by saying 10 to the negative 2, negative times a negative is a positive 3, which means I have 10 to the first power, also known as 10. So the final answer is going to be that my jewelry wire is going to actually be 10 times larger than the hair. Let's take and plug that answer in here. The diameter of the wire is 10 times larger than the diameter of the hair. Our answer is correct. This would be showing your work for a problem like that, and you might just see something like that on your homework tonight. Get busy on it. Let me know what questions you have tomorrow.